Alright, hi guys. This video is to help you with titration calculations. We're going to start with one that it came from your PA, just with some fake data here that I made up. So let's say that this is the data that you got from your PA. So these were the burette readings, like for trial 1, started here, finished here, and this is how much acid you put in your Erlenmeyer flask. Trial 2, started here, ended here on the burette, and this is how much acid you use, and so forth. So when you go to calculate these, you're supposed to calculate the molarity of this acid of unknown concentration for each trial and then average them. I'll just show you how to calculate it for one trial. I'm sure you can repeat that and average them. So, okay, so to calculate the molarity of this acid in a titration, remember that the equation that we want to use is the concentration of the acid times the volume of the acid times the number of hydrogens that can be given away in the acid equals the concentration of the base, or the molarity of the base, times the volume of the base times the number of hydroxide ions that can be given away from the base. Okay, so to calculate the molarity of H2SO4 for trial 1, we need to have 3 of these things and solve for the missing one. Actually, since there are 6 things, we need to have 5 of these things and solve for the 6th one. So let's write down what we know. MA, we don't know. Okay, that's what we're looking for. The volume of acid that we used, the volume of H2SO4, this is our acid. I'll label that up here. We know it's an acid that has H in front because it has H in front. The volume of our acid was 9.98 milliliters for trial 1. Okay, the number of hydrogens, it's H2SO4. It can give away 2 hydrogens, and so the number of hydrogens is 2. The concentration of the base, it's a standard solution, and it's given to us up here in the instructions. The concentration of the base is 3.0 molar. The volume of the base, I have to calculate by taking this minus this. So 49.95 minus 40.00. I made that easy on myself. 49.95 minus 40.00 equals 9.95 milliliters. And then the number of OHs, since my base is NaOH, there's only 1 hydroxide ion for each base formula unit. Okay, so now I just plug these into this equation, and then I solve for my unknown concentration. So I'm going to use this space down here. All right, so I'm going to say MA, leave that as a variable, times volume of the acid, 9.98 mils, times the number of hydrogens equals concentration of my base, so 3.0, times volume of my base, 9.95, times the number of hydroxides, 1. So I'm going to multiply these together and divide by this and this. So the concentration of my acid comes out to be 1.50 molar H2SO4. Notice that when I write my answer, I write the unit and the substance. Make sure you do that on your test as well. Okay, so that's an example from a data table. Let's look at an example of just like a short answer problem that you might see on a test. Okay, so let's look at this problem right here. It says, in a titration, 11.08 mils of HNO3 solution of unknown molarity is neutralized by 7.68 mils of calcium hydroxide that has a concentration of 6.7 molar. What is the concentration of HNO3 in moles per liter? Okay, so because it says titration and neutralized, we know that we want to use this equation up here that we were using before. Okay, so let's do the same thing. Let's write down what we know and then solve for what we don't know. And before we start writing down concentration, volume, and stuff of the acid, let's identify the acid, right? The acid is the one with the H in front. Okay, so that's the acid. The OH, the base, at least in a titration reaction, it has to be a strong base, and all the strong bases have OHs. So the one with the OH hydroxide ion is going to be your base. Okay, So let's write down what we know. Concentration of the acid. It says in a titration, 11.08 mils of an HNO3 solution of unknown molarity. So that's what we're looking for. Okay, volume of the acid, it told us 11.08 mils. Number of hydrogens, it's HNO3, so there's one hydrogen it can give away. Okay, concentration of the base is 6.7 molar. Volume of the base is 7.68 milliliters. And number of hydroxides, this is CaOH2, so it has 2 hydroxides, okay? I didn't say this on the last one, but notice that the units have to match on the volumes, and then it's okay for them to both be in milliliters, okay? So we're gonna take what we know and just plug it in and solve for what we're missing for. So I've got my unknown concentration times the volume of my acid, 11.08, times the number of hydrogens equals the concentration of my base times the volume of my base times the number of hydroxides. Okay, when I multiply these things together and divide by 11.08, I get that the concentration of my acid is 9.29 molar HNO3. Again, remember to put your unit and your substance there in your answer.